Okay, if you've ever worked in software, you definitely know this feeling. You open up an architecture diagram, you're expecting this crystal clear map, right? But instead, what you get is, well, it's a mess. It's confusing, it's outdated, and sometimes it's just plain wrong. It's a super common frustration, so let's dig in and see if there's a better way to do this.
And that really is the million-dollar question we're tackling. I mean, these diagrams are supposed to be our blueprint, our single source of truth for building really complex stuff. So why on earth do they so often end up creating more confusion than clarity? You know, the first big piece of the puzzle really just boils down to people. It's a classic communication breakdown. Everybody has the best intentions, but those intentions get totally lost in a sea of different tools, different styles, and just different ways of looking at the same thing.
So, to kick things off, let's talk about inconsistency. Just think about it for a second. Every team, and sometimes every single person on a team, has their own favorite tool, their own little quirks, their own way of drawing things. And it's this total lack of a shared language that's really the starting point for all the chaos. This quote just hits the nail on the head. When you have to stop and mentally translate every single diagram you look at, you're just burning through brain power. Is that square a database or a microservice? Is that dotted line a real-time call or some kind of background event? All that guesswork, it just grinds development and teamwork to a halt.
All right, next up is a problem that just makes everything worse. Duplication. This is what happens when, say, two different teams need to draw the same part of a system. They don't collaborate, they just each draw their own version.
And here's the real kicker. You end up with multiple sources of truth that completely disagree with each other. The diagram the marketing team has for the user login flow looks nothing like the one the backend team is using. So, which one is right? It makes trying to maintain anything a total nightmare, and forget about trying to collaborate effectively.
And all of that leads us straight into our third big hurdle: terrible interoperability between tools. You know the drill. You try to move a diagram from one tool to another and it just explodes. These programs, they just don't speak the same language, which turns the simple act of sharing your work into a huge technical headache.
Have you ever tried to copy-paste a diagram and it just turns into this jumble of broken lines and text all over the place? Yeah. That loss of detail isn't just a minor annoyance, it can completely destroy the very clarity the diagram was supposed to provide in the first place.
So the communication stuff is a big deal, but it's really only half the story. There's an even deeper, more fundamental problem here. Our diagrams are static snapshots, like old paper maps, trying to chart a world, our software, that is a living, breathing, constantly changing thing.
If you're a developer, you live in version control systems like Git. It's second nature. You can see who changed what, when they did it, and why. But with most of these diagramming tools, that history is either completely gone or so clunky it's basically useless.
And that is a massive handicap. How are you supposed to review changes to the architecture? How do you roll back to an older version if a new design turns out to be a bad idea? Without real version control, trying to manage how your architecture evolves just becomes this chaotic, manual mess.
And that brings us to what is possibly the single biggest problem of them all. The connection between our code and our diagrams is fundamentally broken. They're just totally separate things, manual drawings that exist in a completely different universe from the actual application.
This is the exact moment a diagram starts to become a lie. A developer refactors a service, changes an API, the code is different, the system is different, but the diagram, it stays exactly the same. And over time, that gap between the diagram and reality gets wider and wider, until your documentation isn't a map anymore. It's just a historical relic of what the system used to look like.
So, we have laid out some pretty serious problems here. But what if we could just change our entire approach? This brings us to a really exciting new way of thinking that's changing the game, the as-code revolution.
The solution is actually beautiful in its simplicity. What if we just treated our architecture as code? Instead of dragging and dropping boxes and arrows in some visual tool, what if we actually defined our architecture using text in code files, the same way we do for our applications and our infrastructure?
And this is what we call architecture as code, or AAC for short. It's all about taking the powerful, proven practices we've perfected for managing software, things like version control, code reviews, automated pipelines, and applying them directly to our system architecture documentation. Now, that sounds great in theory, right? But how does it actually work in the real world? Let's take a look at a specific example, a tool called C4 Interflow, to see exactly how this as-code philosophy solves the very problems we've been talking about.
Okay, remember that first problem, inconsistent diagrams? Well, the solution is to use something called a domain-specific language, or a DSL. You could just think of a simple, focused coding language made just for describing architecture. Everybody uses that same language, and then a single automated engine generates all the diagrams. Boom! Perfect consistency every single time.
And what about those duplicated, conflicting diagrams we talked about? With an as-code approach, you define your entire architecture just once in a central model. That becomes your single source of truth. From that one source, you can automatically generate all kinds of different views, a high-level one for execs, a super detailed one for developers, and they're all guaranteed to be consistent. No more conflicts.
And the version control problem? Poof, it's just gone. Because your architecture is now defined in plain text files, you can check it into Git right alongside the rest of your code. You get the full history, you can do pull requests to review architectural changes, you can branch, you can merge, all the amazing collaborative power that modern software teams absolutely depend on.
Now this, right here, is the real game changer. Remember how diagrams get disconnected from reality? The ultimate goal of tools like C4 Interflow is to permanently fix that. By creating tools that can actually scan your codebase and automatically generate these architecture files, you create a living document, a blueprint that is always, automatically, perfectly in sync with the thing you've actually built.
So there you have it. We've gone from a whole set of really frustrating common problems to a genuinely powerful new solution. By treating our architecture as code, we can transform our documentation from a fragile, static artifact into a dynamic, reliable, and truly collaborative part of how we build software.
And that really brings us to the final question, the one for you to think about. Take a hard look at your own projects. Are your architecture diagrams a real living blueprint that actually guides your team? Or have they become historical relics, just gathering digital dust and drifting further and further away from reality? The answer to that just might change everything.